In physics, gravity is a fundamental interaction which causes all things with mass or energy to be attracted toward one another. Gravity is by far the weakest of the four fundamental interactions, approximately 10 to the power 38 times weaker than the strong nuclear force, 10 to the power 36 times weaker than the electromagnetic force, and 10 to the power 29 times weaker than the weak nuclear force. As a result, it has no significant influence at the level of subatomic particles. However, gravity is the most significant interaction between objects at the macroscopic scale, and it determines the motion of planets, stars, galaxies, and even light. On Earth, gravity gives weight to physical objects, and the Moon's gravity causes tides in the oceans. Gravity also has many important biological functions, helping to guide the growth of plants through the process of gravitropism and influencing the circulation of fluids in multicellular organisms. Investigation into the effects of weightlessness has shown that gravity may play a role in immune system function and cell differentiation within the human body. The gravitational attraction between the original gaseous matter in the universe allowed it to coalesce and form stars, which eventually condensed into galaxies, so gravity is responsible for many of the large-scale structures in the universe. Sir Isaac Newton gave us the formula that calculates the strength of the gravity, but the real question was how gravity exerts its force? And what is the mechanism behind it? When Newton was asked by these types of questions, the answer that he gave in his book is that Newton said, he left this topic on the consideration of the reader. In short, he also don't know the answer. Then in 1915, Albert Einstein figured out the answer when he published his theory of general relativity. The reason gravity pulls you toward the ground is that all objects with mass, like our Earth, actually bend and curve the fabric of the universe, called space-time. That curvature is what you feel as gravity. Before getting into the complicated world of gravity, you need to understand, what is space-time? Space-time is exactly what it sounds like, the three dimensions of space, length, width and height, combined with the fourth dimension, time. Using some very brilliant math, Einstein was the first person to realize that the laws of physics work in a universe where space and time are merged together. What this means is that space and time are connected. If you move really fast through space, time slows down for you compared to someone who is moving slowly. This is why astronauts, who are moving very fast in space, age a tiny bit more slowly than people on Earth. When Einstein came up with general relativity, he showed that all stuff in the universe can curve space-time, in physics terms that stuff is mass and energy. Since your brain usually thinks about the world in three dimensions, it is really hard to think about the four dimensions of space-time as a single idea. So to make it easier to visualize, imagine the surface of a trampoline. If there is nothing on it, it is flat. But if you stand on the trampoline, it stretches around your feet and creates a valley with you at the center. If there is a ball on the trampoline, it would roll toward your feet. This is a two-dimensional example of how space-time works. Your mass stretched the trampoline, creating what is called a gravity well that the ball rolls into. This is very similar to how the gravity of a heavy object, like the Earth, pulls things like you and me toward it. The heavier you are, the steeper the sides of the trampoline well. That is why really massive things in the universe, like the neutron stars or black holes, have stronger gravitational pull. Imagine someone went under the trampoline and pushed up. The ball would roll away. This would be a gravity hill, not a gravity well. As far as scientists know, matter, or stuff, always makes gravity wells and not gravity hills. Scientists can imagine things made of exotic matter or energy that would cause gravity to push you off into space, but so far, no one has found anything that could cause gravity to push you away from Earth.
So friends, this is it for now. If you like the video, then don't forget to like, subscribe and share it with your friends. We'll try our best to bring you such amazing facts about the universe. Till then, take care and goodbye.